just a quick recap. I told it in the last talk that is Soil is my newest pet project to make this database, and I'm just going to say it's already on GitHub, so you can go there, complain, comment, love, everything. I'm interested for every feedback. But now for something completely different. So the point is that for me, all this database and concurrency stuff, you always come to stuff, object graphs. The best on object graph is the graph, and the downside of it's a graph, so it's hard to manage. So if it comes to concurrency, graphs are not naturally willing to cooperate. So you have basically two choices. Either you lose identity while you copy objects, or you help objects to stomp on each other's feet. So, and that's something that drives me for a longer time, and I thought it's a longer experiment, and I needed Marcus that he explain me again why it's working, because I forgot. But it's a riddle. I think all the ephemeral riddle you enjoyed in the last ESUG, right? So speak after me. Objects have instance variables. Yeah? Instance variables are slots. Slots are objects. So slots can have state. And that state can be another slot. That other slot can be a process local slot. So, yeah, that's, who could follow? Well, I could barely in the morning, so I hope I don't mess it up. So what we do is we create a kind of a memento slot, which has an instance variable that when created a class, it installs yet another instance, another slot called memento slot with the name of the other, and installs a process local slot. So that means whenever we create an object, we have the memento slot just saying, okay, I have the object, and when I read something from the instance variable, if the memento is nil, I read it from the object. If someone is writing it, I write that value in the memento slot. And if I read it again, I read it from the memento. So the same is for collections. We do a copy in order to be independent, so we can make a detection if it changed afterwards. So, and now look at it, it's process local slot. So that means that this object, when being written, is in this process, it looks different than in any other process. So that means whenever you write an instance variable, it writes the real value, the new value, into the process. And so different processes write to different stuff, and each memento is per process. So you read different values per process. The end result is that the test, I'm not sure if you can see it. So there's two, in the middle there's two things, fork with transaction, the code is up there. So TX current transaction is a dynamic variable, which is also attached to the process. In the fork with transparent, we say first, okay, the object should be nil, and then we write a value to that object, and then we wait. And then after the semaphore is unlocked, we just check that the value is still the same thing. And that we do in different processes. So the first one is a fork, is another process, and that one. And finally, at the beginning, because the transaction is not committed, it should be nil. So, and this is the test, well, it's green, you should say, that we can say that every object can appear with different shape in different processes, which could make the, so if we have in the normal Pharo image, if you have web request or something, for each request the process is spawned. So that means you have access to the whole graph, but as soon as you write it to the process in the memento. And only that process can access the state, and every other process can still work with the old object, write other values, and at the end, and everything in this TX current transaction, you just say, oh, I have been changed, so put me in the dirty list, yeah, on each. So, and the transaction is the same process, so every process has its transaction object, and if you leave the block, you can just say, transaction commit, give me the dirty list, and now really write it in the object which is in the global heap, in the image. That's done. That's a little experiment about transactional memory. It's a bit complicated, I say, but it's the best I could come up so far. But it's still a riddle. Done. Thank you.